Pause the video if you'd like to have a go at this question. The answer will be coming up in about 10 seconds. Okay, so for part A, we're going to multiply through by both denominators. So the numerator of the first fraction and the numerator of the second fraction. And we'll move a little bit so we can fit in the right-hand side. Both denominators multiplied together. We're actually going to leave in the denominators that are already there in the two fractions and then cancel out. We expand our brackets that we have left over and we add those terms together and we expand the bracket on the right hand side. We're going to go on to solve this equation, and what we notice is we have an x squared on each side so we can cancel, a negative bx on each side so we can cancel, a negative ax on each side so we can cancel, and we're left with x squared equals ab. Now this square roots only when a times b is positive. So either a and b are both positive numbers or they're both negative numbers. That's the only way we can multiply two numbers together to get a positive. Now they cannot be equal to 0. So we have strict inequalities. And if that's the case, then we get two distinct values of x, which is two distinct roots. Okay, so we're going to take a similar leap that we did previously, but we notice we have this extra added c over here, and we're after one solution this time, not two distinct solutions. So we're going to go through the same method of multiplying through by both denominators. And we see the cancellation happening. And the expansion and addition of the four terms on the left-hand side. And we already can expand two of the brackets on the right-hand side. So we're going to use the working from our previous example. If you spotted the error I just made, don't worry, I'll correct it in a minute. So if I expand my two brackets here and do 1 times each term, this is what I get. And if I do c times each term, I get c times each of the terms above. So I'm using what I did previously and multiplying those four terms by 1, which is just the same as those terms originally, and then by c, which puts a c inside each term. Now, I'm going to rearrange this, moving all the terms to one side and making it equal to 0. We can cancel some terms first, just as we could before, and here comes the correction. I notice it should be a minus ax, so that it cancels with the minus ax on the other side. Sometimes you only see errors when you go through these kinds of processes, and it's why it's so important to have a really, really strong written style. Now, if I move all of the terms to the left-hand side, so the x squared terms, 1 and c, I get 1 minus c x squared. Now if I look at the x's, I've got an a c x and a b c x. They both become positive, and I can take a factor of x and c out, and that's why it becomes c a plus bx. And then I move the final two terms, ab and abc, over. Again, those could be factorised, but I haven't factorised them. I don't think it's too important right now. Okay, so we want one solution. Now this is a quadratic. You can see A, B and C are quite complicated things, but it's still just a quadratic. So we're going to set up the equation b squared minus 4ac, where A, B and C are the things that you see highlighted on the screen. A, B and C. So b squared is all of this squared, which looks like that. A is 1 minus c, and c is those two negative terms there. Okay, so if we expand this really nasty double bracket, or if we expand the 4 into the single bracket first and then expand the double bracket, those are the first two terms, and here are the next two terms. Minus 4 ABC and minus 4 ABC squared. Now if we expand all of this, and we do it quickly, we can just get this. A plus b squared is quite easy to expand, and then we're just timesing everything by c squared. So let's write that out a bit more clearly, so we see all of the terms. What we start to see is this negative term over here and this positive term over here they're like terms, and they give you minus abc squared. Now that's just a change of sign, which means we can factorise that. There's a factor of c squared that comes out, and then you should be able to recognise a minus b squared. Now this is the clever trick, because in our final answer we've got an a minus b squared, so that's where it comes from. All of the other terms cancel out except for the 4ab, and we have found our result. It's a great satisfaction to be had in these questions when you arrive at what it should be, hopefully. Okay, so we're going to start by looking at the c squared that they give you in the final part of the question. And we're going to change the way we look at the number 1 by making it a minus b squared over a minus b squared. That is undoubtedly the number 1, but it now has the same denominator as the other. Now, what I like about this problem, and doing it from this angle, is there's a really cheeky, sneaky, fun rule. So this is a square number, and this is a square number, and this is the difference of two squares. So that's quite tricky to spot, I would say. You can expand everything and simplify it, and it should still work. However, using difference of two squares, if we add those two things together, the b's are going to cancel out, and we're going to get 2a. And if we subtract them, then the a's are going to cancel out, and we're going to get negative 2b. So we're going to get 2a times negative 2b, and that's where the minus 4ab comes from. Really clever. I'm going to write it out in full, even if it's at slightly slant angle. You should be able to see the algebra coming together. And there we go. First bracket is 2a. The second bracket, once we expand the negative into that final factor, we get minus 2b, because the a's cancel out. And there we are, we're finished on that result. One final step to do is regarding this inequality at the very end. It looks like it should be straightforward, but for me conceptually it's quite nasty. Okay, so we're going to start with a fundamental principle that you're aware of. All square numbers are positive, and from this we're going to deduce that c squared has to be between 0 and 1. Okay, so first of all, c squared has to be greater than 0 because it's a square number. So we've already just explained the left-hand side. That's all we need to do. We're told c is non-zero earlier in the question, so that's why it's not equals to. Now the other square in this problem is the big fraction with the square sign around it. Now that is greater than 0. So a negative version of that is less than 0. And if we add 1 to both sides of our inequality, 1 minus that square number is less than 1, or equal to 1. However, the thing we've just writing down now, that is less than or equal to 1, is c squared. So c squared is less than or equal to 1. And that's it. C squared is greater than 0 and less than or equal to 1.